Hi everyone, Mr. Geiselart here. Today we'll be looking at graphing y equals sine x and y equals cosine x. That is going to go along with the assignment for 4- homework number 10.1, Intro to Graphing Sine and Cosine. Whenever we do any kind of a graph, the first thing we should always do is figure out how are we going to scale the x-axis and the y-axis, and what units do we use for the x-axis and the y-axis. So let's take a look at another slide to see if we can figure this out. So this slide is going to demonstrate how the unit circle is related to the graph of sine and cosine. So what we're going to do is we're going to start by going around the unit circle. As we go around the unit circle, the distance away from the x-axis is being plotted at different angles that are rotated around the circle. So I'm just going to let this go through one full cycle, or actually two full cycles, and then we're going to talk a little bit about what everything means and how we get those values. So when we're looking at this here, a couple of things I want you to notice. First of all, when we start off, we're at 0, 0. If you go to the y-axis at 0 degrees, in other words, in standard position where we start, notice that it is right on the x-axis. That means at 0, we start at 0 because that's the distance away from the x-axis. So 0 degrees is at 0. Now, the first part where it's interesting is this spot right here at pi over 2. When we go in the positive direction around the unit circle, the first stop we make here is at the highest it's going to get. Because this is a unit circle, the radius of the circle is 1. So at pi over 2 degrees around the circle, or 90 degrees, that is where we hit a maximum value. As you continue to go around the circle, the next spot we're going to come to is going to be pi, or 180 degrees. Now, at pi, we're no longer, we're actually on the x-axis again, so that means we're a distance of 0 away from the x-axis. As you continue to go around the circle again, you're going to come around here and you're going to hit 3 pi over 2, or 270 degrees. Now when you hit 3 pi over 2, you're at -1. So that's why we're down here at -1 at a minimum. And then when we complete our circle, we're back to 2 pi, or 360 degrees, which brings us back here. So that will bring us through one full period of sine. Goes like that. Now, if we keep going around the circle, that will just keep happening over and over again, and it will continue on forever, because once you go around the circle, you start over again. Okay, what we're going to talk about now is, why is it that the distance away from the x-axis is the value of sine? Well, that comes back to our unit circle. So what I'm going to do is I'm going to pick a point on the unit circle. I'm going to pick that point right there. If I make a triangle out of this, I'm going to go straight down from there, and I'm going to go straight over from there. Now, we have the coordinates of this point on the circle are negative square root of 3 over 2 and 1/2. I'm sorry, square root of 3 over 2 and 1/2. So this is the square root of 3 over 2, and this is 1/2 here. Because this is a unit circle, that distance there is 1. Now, the angle that we have here is the same as the central angle that we have here. So 30 degrees around the arc is the same as 30 degrees central angle. So if I want to find the sine of 30 degrees, remember that equals opposite over hypotenuse. Well, from my angle here, the opposite side is 1/2, and the hypotenuse is 1. So the sine of 30 is equal to 1/2 over 1. And we know that anything over 1 is just itself, so the sine of 30 is equal to 1/2. Now, I can come down and graph that. You'll notice that down here, I have my x-axis labeled in degrees this time and not radians, and it's marked every 15 degrees and labeled every 30 degrees. Here, in the y-axis, we're only going from 0 to 1, and then from 0 to -1. So if I wanted to plot the point 30 and 1/2, I would go to 30 and up to 0.5, and that's going to be my point. Now we can continue to go around the circle, and the next one I'm going to stop at is 45 degrees. So the sine of 45 degrees is going to be just my y distance, the square root of 2 over 2, because that's the opposite side over 1. Well, the square root of 2 over 2 is approximately 0.707. So if I go to 45 degrees, I want to go to about 0.707. Continuing around the circle, we're going to go to the next one here, and that's going to be the square root of 3 over 2. So the sine of 60 is equal to the square root of 3 over 2. And then if I want to plot that point, all I have to do is go find 60. The square root of 3 over 2 is approximately 0.866. So 60.866, and I go up to here, and then we go to 90 degrees, and that's just going to be 1. So at 90 degrees, it's going to be 1. Now, if we want to talk about going in the negative direction now, I'm just going to go ahead and erase some of this stuff here to make it a little clearer, a little easier to see. And now let's go in the negative direction. If I were to go in the negative direction, this distance right here is a negative 30 degrees. So when I draw my triangle that looks something like this, my y value is going to be negative 1/2. So at negative 30, I have to go to negative 1/2. Then at negative 45, the next one right here, we have the negative square root of 2 over 2. And remember, negative square root of 2 over 2 is approximately negative 0.707. And then we're going to go down here. And then the next one at negative 60 is going to be 0.866. And at negative 90, it's going to be at negative 1. Okay, now we have part of it, and it's going to continue on, and it will go something like this. Whoops, something like that. And it'll continue to go on and back here and go something like this, like that. Now, I'm going to talk a little bit later about how to find these values in your calculator so that you can graph them. But the main thing you want to pull away from this page here is that the sine of whatever angle you're doing, theta, is just equal to y on the unit circle. Okay, let's take a look at cosine now. We knew sine is just going to be the y value on the unit circle. So what about cosine? Well, sine is the opposite over the hypotenuse, and we figured that out by drawing in a triangle. This is the opposite, this is the hypotenuse, this is the adjacent. Well, notice that the adjacent is just going to be the x value that you have here. So the x value for 30 degrees is going to be the square root of 3 over 2. And the hypotenuse is still equal to 1. So just like we said that the y value is equal to sine, the cosine of theta is equal to the x value. So when I start off graphing this, the cosine of 30 is just going to be the square root of 3 over 2, which is approximately 8.866. So at 30 degrees, 0.866 is going to put me about here. Now, what about at 0 degrees? Well, at 0 degrees, I'm right here. Since this is a unit circle, the length of that side will be 1. So at 0, it's equal to 1. As I continue to go around the circle, again, I'm looking at the x values now. My x value for the cosine of 45 is equal to the square root of 2 over 2, which is approximately 0.707. So let's plot that point right there. And then if we want to do the next one, the cosine of 60, my x-coordinate is 1/2. So if I go 60 and 1/2, then the next one is going to be 90, which is going to be 0. Because I'm right here at 90 degrees, my x-coordinate is 0. And so I can plot that point right there. Now, if I go in the negative direction, just like we did last time, let me clear this up over here. If I want to go in the negative direction, negative 30 degrees is just going to put me at a positive square root of 3 over 2. So negative 30 is a positive 0.866. And the cosine of negative 45 is equal to, going further down my unit circle, the x is just the square root of 2 over 2, which again is about 0.707. So we'll plot that one. And then the next one at 60 degrees will be 1/2. And then at negative 90 degrees, that's going to be 0 again. Now, if you were to continue this around the unit circle, you'll find that the graph looks something like this. And that's just a quick sketch. It doesn't look exactly like that. But that's what you're going to be doing in this assignment. You're going to be plotting these points and figuring out what it looks like. Okay, when plotting the points, there's an easier way of doing it than just trying to go around the unit circle and find the x and y values. You can actually use your calculator to do that. And here's a little video that's going to show you how that works. Okay, what I'm going to show you how to do in this video is to use your graphing calculator to make a table of values. This will make it pretty easy for you to graph the sine and cosine functions. One thing you're always going to have to be careful of whenever we're working in this unit with sine and cosine is we need to know whether we should be using radians or degrees. For this question, we're going to be using radians. So if you hit the mode button and go down a couple of clicks, you'll see that you have the radian and degrees. If you want the radian mode, just make sure you block over the radian, hit enter. If you want the degree mode, go over degree and hit enter. For this problem, we are going to want to use the degree mode. Once you have it in degree mode, then we're going to go to y equals. Once in y equals, we're going to graph y equals sine of x. So it's going to look something like that. Now, when we graph this, you'll notice that we don't see very much. There's a little bit in there. That's because the window isn't correct. So let's go ahead and do the window. The first thing I'm going to do is, since we want to go from negative 360 degrees to a positive 360 degrees, I'm going to change my x window from negative 360 to positive 360. The y, we're only going from negative 1 to positive 1, so I'm just going to go negative 1 to positive 1. Now when I graph it, I'll get a much better idea of what the graph actually looks like. Now, if we want to look at this value in the table, I can hit second in table, and I can see all my values. Now, this is just counting up by 1 degree at a time. We're not going to want to count up by 1 degree at a time because that would be a lot of numbers that we would have to plot. What we want to do is we want to count up by 15 degrees at a time. So if you hit second and table set, we're going to start our table at 0. This delta table means what should we count by? Well, we're going to count by 15 degrees each time. So once I do that, if I go back to my table now, it's counting by 15 degrees. So when you plot this in your assignment, all you need to do is go to your table and then plot these points for each 15 degrees as you're going through and do this. So if you scroll down, you'll see all the positive values, and then if you scroll up, you'll go to the negative values. So you're going to want to plot each 15-degree increment up to 360 and then back to negative 360. Okay, I hope that was helpful, and good luck with your assignment.